Now let's see how we can create a custom output parser for LangChain. This will allow us to strip out other data in a chain that we want to extract from the output, from the unstructured output that large language models typically produce when you prompt them. We are assuming that you use OpenAI, and I have the environmental variable here. It also tries to grab it from the secrets that you can store inside of Google Colab if you're using Google Colab. So custom output parsers, there are two ways that you can create one. You can use the RunnableLambda in the LangChain expression language, and you can also insert one from the base class for output parsing. So you either extend the base class or you use a lambda. The following, and a lambda is just basically a kind of a anonymous function that you pass around in Python. So the following code creates the basic LLM to use. You can see I am using and assuming OpenAI. You can swap that out for really any large language model that you want, and LangChain will take care of the differences. Here I am creating an output parser that basically just sort of flips the case. So hello world like that would become hello world like this. And basically I just create the parse for it, and then I call swap case, which is a standard Python function. And then you can see that I simply can put my output, because it's essentially, I'm passing the lambda of it. The name is parse, but then I pass basically the lambda, which is the function body. And then the large language model we invoke it with hello, and then it's going to take not the word hello that I gave it, but what the LLM response to hello would have been. And it flips the case, as you can see there. That's using sort of the lambda approach. If you want to inherit from the base class, you can certainly do that as well. Here I am creating something called a boolean output parser, and I am extending from the base output parser that is built into LangChain, and that I'm telling it to expect a boolean, or that we're going to be doing booleans. And it's a custom parser to interpret yes/no strings in Boolean values. And we get to see really how adaptable these large language models are actually for these kind of things. And I define the true and false values. It cleans the text by stripping it, and then so it strips the value, and then it makes sure that the values are as expected. So you can see the flexibility that it has here. Invoke with yes, it's going to say true. Invoke with okay, it's also going to say true. Invoke with okay and no, true but false. And it's quite adaptable. It can continue to, it can deal with all the different types of values that could signify true or false. Next, we're going to see something that strips non-Python text. So this can be useful. Sometimes, very often, you will get a result like this. Like if I asked it to calculate the value of pi using Monte Carlo, or using other methods as well, it'll often put in a bunch of preamble, and then it gets into the Python. You might want a way to strip off that preamble sort of a text. So here we basically find all of the Python blocks in there and rip off everything else that is there. And then you can see the example that we have here. It only grabs the embedded Python text and removes everything else. And then using that, we can create the CodeOutputParser that is going to use that remover that we just built. And then when I asked it this kind of thing, you get just text code back from it. All right, thank you for watching this video, and please subscribe to the channel so that you don't miss any other AI projects or more information from this class. Thank you very much.